Welcome back, guys. Today I'll be looking at finding the reference angle. I'll also be focusing on the cast diagram and then I'll be answering questions. Let's get started. Positive and negative angles. When we talk about a positive or negative angles, we talk about the direction. Once it's positive, we go counterclockwise, but if it's a negative angle, we go clockwise. So it's all about my direction. So let's look at some examples. If I talk about 30 degrees, it's telling me that it's positive and I'm going into a counterclockwise direction. So 120 degrees. Now this is 0 to 90 and then from 90 to 180 degrees. So it means I'm going a counterclockwise direction. So I will have 120 between 90 and 180. If I get a larger number, say for example, we have 230 degrees. 230 degrees will fall between 180 and 270. So going into a counterclockwise direction, we see that from 0 to the line, I have 230 degrees. Now, if I'm going in a clockwise direction, then my angle has a minus. So if I have negative 30, this is a 0, and then this will be negative 90 because I'm going in the clockwise direction. This will be minus 180. Then I'll have minus 270 and then a complete revolution. So this will be minus 360. So negative 30 is just telling me that I'm moving in a clockwise direction. So here I'll have 30 degrees going in the next direction. So that's why it's minus 30. So negative 120 would fall between negative 90 and negative 180. So all of this will represent minus 120. So if I have negative 200, it will fall between negative 180 and negative 270. And all of this represents minus 200. Now we separate each quarter as quadrants. So these are quadrants. And as you realize, we have it going 0, then 90, then this will be 180, and then I'll have 270, and complete revolution is 360 degrees. So you should be seeing that I'm doing this. So we have the first, second, third, and fourth quadrant. Now, reference angle is a positive acute angle that lies between the terminal side of theta and the x-axis. So for quadrant 1, as you can see, the reference angle 60 degrees is between the terminal side and the red line, which is the reference line. Same thing if I have minus 280, it will be going in the next direction. So as you can see, I am going into clockwise direction, but the reference angle is between the x-axis and the red line, which is the terminal side or the terminal line or terminal ray. So if I have the second quadrant, 150 degrees, as we know, it's between 90 and 180. So here we have the red line. But the reference angle is between the x-axis and the terminal ray. So that's why this would be 30 degrees. 150 plus 30 will give us the 180. So if I look at this, minus 225, right? But to get the reference angle is between the terminal ray and the x-axis. So what you could do is say 225 minus 180, and that would give us the 45. Or you could have just analyzed and say. For quadrant 3, we have 230 degrees. As you can see, we have the reference angle being between the terminal line and the negative x-axis. which would be 50 degrees. While we have for negative 110, here the reference angle is between the terminal line and the negative x-axis. So always between the terminal line, which is the red mark, and the x-axis. So even if I have 300 degrees, the reference angle is between the terminal line and the x-axis. Same case here, it's between the terminal line, although it's negative 75, the angle is between the terminal line, the terminal ray, and the x-axis. So that's 75 degrees. Here, if I have 330 degrees, I know I'm moving in a clockwise direction. So I'll be moving from 0 to this terminal line, and this represents 330 degrees. But the reference angle is between 0 and the reference line. So what you can do is say 360 minus 330, and the difference will give us the reference angle, which is 30 degrees. So in this case, the reference angle is between the x-axis and the terminal ray. Now, if I have 240 degrees, we can say that 240 will fall between 180 and 270. So from 0 to this terminal line, I know it is 240 degrees. However, the reference angle is between the terminal ray and the x-axis. So this is where it falls. Now, I can say 240 minus 180, and that will give me the reference angle, and that's 60 degrees. So this is my reference angle, which is 60 degrees between the terminal ray and the x-axis. Now, if I have a negative angle, it's telling me I am moving in a clockwise direction. So it means I will have to change up the angles that I have here, where it will reflect the direction that I'm moving. So it means this will be negative 90 moving in a clockwise direction, negative 180, negative 270, and a complete revolution will be minus 360. So minus 300 will be between negative 270 and negative 360, and I'm going in the clockwise direction, and the reference angle is between the terminal ray and 0. So to get it, I will say 360 minus 300. Forget about the sign. Just say 360 minus 300, and that's 60. So the reference angle is 60 degrees. So by now we're seeing that we have different quadrants. So each quarter we have a quadrant. We have the first, the second, the third, and the fourth quadrant. We also see the revolution 0 to 360 degrees. In the first quadrant, we say all angles are positive between 0 and 90. So I sine 30 degrees. It's in the first quadrant, so it's going to give me a positive value. If I cos 30 degrees, I will get a positive value. And if I tan 30 degrees, I will also get a positive value. In the second quadrant, I have between 90 and 180. Only sine will give me a positive value. So if I have sine, say for example, 120 degrees, that will give me positive, but cos of 120 will be negative, and also tan of 120 will be negative. In the third quadrant, tan alone will give me a positive value. Everything else will be negative. So I have tan 200, and that is positive. If I have cos 200, that will give me negative. And if I have sine 200, that will give me negative. Now the final one is the fourth quadrant. Only cos is positive. So cos 300, I will get a positive angle, while sine 300, I will get a negative angle, and tan 300, I will get a negative angle. Now let's look at an activity. Express the following trigonometry ratio in terms of the same ratio where we get the equivalent positive acute angle. So the positive acute angle for this. Now, let's look at cos 110 degrees. Now, where is 110 degrees? First, I will draw my axis and locate where is 110 degrees. It's positive, so that means I'm going counterclockwise. And looking at this, it's between 90 degrees and 180. So this is a region where I will draw my terminal ray. So 110 degrees is from 0 to the second quadrant. This represents 110 degrees. Now, the positive acute angle, acute is less than 90, so that's a reference angle, and that is the difference between 180 and 110, and that's 60. So in this quadrant, cos is negative, so it means I'll get cos 110 to be a negative value. So it's equivalent to negative cos 60 since it's in the second quadrant. Now, minus 120, so it means I am going in the clockwise direction. So from this, I will identify where is sine negative 120. It's between negative 90 and negative 180. So it is from 0 degrees to negative, between negative 90 and negative 180. So drawing my terminal ray in this region. Now, after doing this, the reference angle is between the terminal ray and the x-axis. So in order to find out what is the reference angle, forget about the signs. Let's think about what is my acute angle, which should be positive. So you can say 180 minus 120, or you can just look at it and say if I'm at 120, let's forget about the sign, but you're at 120 and you need to reach at 180. How much more do I need to reach there? It will be 60 degrees. So the reference angle here will be 60 degrees. Tan 320, what we're going to do is, once again, label my quadrant, have my angles. It's going in an anti-clockwise direction, hence the reason for me to be labeling it as you're seeing it. 320 degrees is in my fourth quadrant, and we know only cos is positive here, so I'm expecting tan 320 to be a negative value. Now the acute angle is between the x-axis and the terminal ray, and we can just see 360 minus 320, and that will give me 40 degrees. Now, because it is in the region where tan is negative, then the answer should be a negative answer. And 40, tan 40 would be positive. So we will say the answer is negative tan 40. Now I have cos minus 220. The minus is telling us that we are going in the clockwise direction. So if I'm going in clockwise direction, then I have to label my axis as how I am moving. So here you're seeing me having it going in the clockwise direction. Now we need to identify where minus 220 will lie. It will be between negative 180 and minus 270. So I draw my terminal ray. So I'm moving to draw my terminal ray, and then here we're moving. This is 220 degrees in the clockwise direction, hence the minus sign. Now I need the reference angle, which is a positive acute angle, and it will be between the reference line and the terminal rate. So as you see, we can use 220 minus 180. Forget about the sign, just say 220 minus 180. And that will give us the acute angle, which is 40. And because cos is not positive, cos minus 220 is not a positive value, then it means what cos 40 will have to have a minus sign in front of it. So I'd have minus cos 40 is the same thing as cos minus 220. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.